Hello guys, this is the paper 2 of April 2 shift 2 JEE Main 2025. Hope you guys had rocked it. This is having some mixed questions. As far as I asked with my students, these questions it is not so difficult, or at the same time it is not so easy also. I just received a mixed feedbacks about this question paper. As far as I know, these are simple questions. You guys can, you must be rocked it, right? So let's get started with the first question. In 3,3 dimethyl hex 1-ene 4-ine, the number of sp, sp2 and sp3 carbon atoms are. So that is the question asked. Okay, so first of all, whoever know the basic organic chemistry can easily solve this type of questions. What is 3,3 dimethyl hex? So I'm just going to add 6 carbons. 1, 2, 3, 4, 5, 6. Okay. Then 3,3 dimethyl. So from here I'm adding, taking that as in third position. So dimethyl, cool. And then 1-ene. So since I have taken this carbon as a third carbon, so that becomes 1-ene 4-ine. Then this is 4-ine, right? Remaining are hydrogens. That's it, right? So remaining 2 hydrogens will be there. Here 1 hydrogen, no hydrogens, no hydrogens, no hydrogens, and finally 3 hydrogens. Okay, so how many are sp2, sp3 and sp carbons? So you can see this, these are sp3, right? So there are 3 sp3s. Any other sp3? What about this carbon, which is also a sp3 carbon, isn't it? So as you can see, 4 substituent attached. So this is also sp3, right? So 4 sp3. So it should end with 4. So answer must be this one. Let's take the sp and sp2 as well. So sp carbons are these two, correct? And what about this one? These are sp2 carbons, right? So answer to this question is 2, 2, 4. See, the questions are very simple. You guys are very lucky. Then nature of compounds TiO2 and TH is respectively, I think it's supposed to be TH2. Okay, so compounds of these two, tellurium with oxygen and tellurium with hydrogen. So you guys can see clearly these are from oxygen series, isn't it? So oxygen, sulfur, selenium and tellurium. So as we are moving down the group, the lower oxidation state stability will be increasing. So tellurium always want to be in 2+ oxidation state, right? So here this is in Te4+. So it can easily undergo, gain 2 electrons to undergo reduction to form Te2+. Itself reduces, so it can act as an oxidizing agent. And what about TH2, which can act as a reducing agent, where oxidation state here, that is Te2+. So option A, oxidizing and reducing respectively, is your right answer. Then statement 1, melting point of neopentane is greater than that of N-pentane. And the statement 2 is neopentane give only one monosubstituted product. Okay, so melting point of neopentane. What is neopentane first of all? Neopentane, which is something like this, right? So pentane which means 5 carbons. It is connected like this. So what they are asking is melting point. We have to compare the neopentane with N-pentane. So what is N-pentane? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is N-pentane and this is neopentane. We have to compare the melting point. Melting point is dependent on the, first of all, the van der Waals forces. Forces of attraction. Not van der Waals forces, forces of attraction. Here these are aligned with van der Waals forces both. So that is ruled out. The second one is majorly dependent on the branching, right? Symmetry. So while comparing these two, more the branching, the melting point will be higher. It's just opposite to the boiling point. Don't get confused over there. So neopentane will have more melting point than the N-pentane. That is true. Okay. So what about the second statement? Neopentane give only one mono-substituted product. So whatever the hydrogens you can substitute over here, the mono-substituted product will be the same. Right? This carbon is not having any hydrogens. The remaining carbon which is having the hydrogens are, the mono-substituted products are same. So which makes this statement as true. So both the statements are correct. Next question, sodium nitroprusside test is used for the detection of which of the following species in organic compounds? Sodium phosphate, SO2 and S2 sulfide. Okay, so which would be right? Very straightforward question, right? If you know or don't know, that's it. There is no need of thinking much about these questions. It's just a straightforward question. What is the answer? It is for the test for sulfides, guys. Right. So Na2S, which is treated with this big complex. I have told you about this already. Right. Big complex to form a Ne4Fe Cn 5 times NOS. This is also here forming a very good compound, very big and complex. So this test is for sulfides. Then the next question, 0.5 gram of organic compound heated with CaO in a CO2 atmosphere at 300 Kelvin. The volume of N2 gas collected over H2O is 60 ml. If aqueous tension is 15 mmHg at 300 Kelvin and the pressure recorded is 715 mm of Hg, then calculate the percentage of nitrogen in organic compound. Okay. So what I am mentioning, what we have to find out? We just have to find out the nitrogen percentage, right? So first of all, let's calculate the pressure. So the pressure of nitrogen, it comes out to be, here I am having recorded, that is 715, and the aqueous tension, that is 15 mm of Hg, both are in the same units. So the pressure comes out to be 700 mm Hg. Okay. So if you want to convert it to ATM, what I have to do? Just divide it by 760. Then this is ATM. Let's check whether other values are, we need that in ATM or not. Let's stick with mmHg for now. Okay. So the next thing is that for finding out the nitrogen percentage, for N2 percentage, what we have to do? We have to know the mass of N2, then mass of organic compound, right, into 100 to get the percentage. So do I know the mass of nitrogen? No. Am I know the mass of organic compound? Yes, I know, that is 0.5 5 grams. So I have to find out the mass of nitrogen. How can I find out the mass of nitrogen? So mass of nitrogen can easily find out from the number of moles. So how can I find the number of moles? So number of moles, which is the simple formula, PV is equal to nRT, right? Ideal gas equation. So here you can see P value, pressure, we already know, and then 700 by 760, and then number of moles we are going to find, so which will become PV by RT. So pressure I am substituting over here, fine. Volume, what is the volume? 60 ml. So I am going to write it as a liters. So 60 into 10 to the power minus 3 liters. Then R value, check the units of others, which is in Kelvin, and we took it as in ATM. So I have to mention it in 0.0821. If that is in joule per Kelvin, then you can take it as 8.314. Here we have to take it that as 0.0821, and the temperature that is mentioned as 300. Okay, so from here I will get the number of moles of nitrogen. So then what I have to do? So once I get the number of moles of nitrogen, then I have to multiply it with 28 to get mass of nitrogen. Okay, it is so simple. So upon doing the calculation, you will ended up with mass of nitrogen. So you just need to substitute it over here. You will get around 12 point something. While rounding it off, you will get approx 13. 13 is the right answer to this question. Then the next question, which is based straight to NCERT. NCERT in this DNF block, D block elements chapter, you can find a table. So always remember guys, inorganic chemistry means they will ask the questions, 99.9 questions from NCERT only. Okay, thorough with the NCERT, thorough with the tables especially. Okay, so this question, see, enthalpy of atomization. Enthalpy of atomization, you can't find it in the theory part, but it is there in the table. Okay, so it's a very straightforward, whether you know or not, that's it, right? So here you can see the order is nickel, after that copper, manganese, and then zinc. So that is the answer to this question. Then the next question, which is the column based one. In column 1, I am having Wilkinson reaction, then Lucas, Woods, and Gatterman-Gush. Okay, very simple organic question. Hope whoever watched our crash course videos, they aced this exam with 99+ percentile. So the column 2 refers the reactions. So the first part is given as benzene ring reacting with COHCl, and the second one is RX with sodium ether. The third one, it is given as alcohol, secondary alcohol with ZnCl2, and the fourth reaction is given as CH3CH2Cl with NAI acetone. So which of the following matches? The first thing first, Wilkinson reaction, what is that? You just go with the production of halo, that is particularly iodine, right? So iodo compounds which can be prepared from Wilkinson reaction. The twin sister of Wilkinson is Schwarz, that is for fluorine compound, right? Okay. Then the next one is Lucas. Lucas test is for the distinguishing primary, secondary, and tertiary alcohols. So undoubtedly that belongs to third one. Then Wood's reaction. What is Wood's reaction? It's for the preparation of higher level alkanes. So this will give RR. Right. And finally, whether you know about this reaction or not, but other three are already matched. So which is very easy. Catterman-Koch reaction, that is CO HCl with benzene, that will give you benzaldehyde. As simple as that. Let's say this question, which of the following complexes has CFSE value neglecting pairing energy? Okay. So first of all, these compounds are lies in octahedral, right? So octahedral means how the CFSE goes EG and T2G, right? So T2G here comes and then EG. So what would be the formula for CFSE? So formula for CFSE is, we have to do -4 into number of T2G, then comes plus 0.6 into number of electrons in EG level, right? So if you are, this question is bit lengthy, but you can do it in 1 or 2 minutes. Here you can see, first of all, you have to neglect the incorrect answers. So that may save your time. So here you can see zinc 2 plus. Zinc 2 plus means it will be in 3D10 state, 4 is 0. So 3D10 is fully filled. So you will get the CFSE as 0. So no problem. Then Mn H2O6 2 plus. So Mn 2 plus. Here, let me erase these things. So here you can see Mn 2 plus means it will be 3D5, 4 is 0. So Mn, and this is in weak field ligand. So what will happen? First, this will form a T2G3 EG2. And what answer you will get? -4 into 3 plus 0.6 into 2, which would be 0 once again. This 1.2, 1.2, 0. Then comes COF63 minus, which is in cobalt, which is in 3 plus oxidation state. So 3 plus oxidation state means how we can proceed. So cobalt number is 27. So 3D7, 4s2. So this becomes 3D6 now. So fluorine, which is in weak field ligand, so then it will form, let me erase these things for now. Okay, so it will form T2G 1, 2, 3, 4, 5, 6. So T2G4 EG2, right? So upon substituting that, what will you get? So T2G4 and EG2. So 1.6 minus 1.6 plus 1.2, which will become 0.4 minus 0.4. Okay, so how many pairings are there? Only one pair. Okay, so they are asking for highest CFSE. So let's do with the EN also, ethylene diamine also. Here you should know what will happen. Is it a strong field ligand or weak field ligand? So what can happen over there? First of all, what is the oxidation state? Which is again cobalt 3 plus, which will form 3D6, 4 is 0. EN is an absolutely a strong field ligand. So it will form T2G6. So T2G6 means -4 into 6, which is 2.4. Minus 2.4 with how many pairings? 3 pairings. They are asking us to neglecting the pairing energy. So we are neglecting that. Still we are getting 2.4 as your answer. So this becomes your answer. Then, which one of the following is at least one lone pair at the central atom and different bond lengths? Okay, so if you could see, here we have XeF4, XeF2, SF4, PF5. Okay, great. So XeF4. So how many lone pairs and how many bond pairs? I have told you a method to find out lone pairs and bond pairs. Is it? So here you go. XeF4 will have 4 bond pairs and remaining what I have 4. So total of the hybridization becomes sp3g2. Right? So what about XeF2? XeF2 will have 2 bond pairs and remaining are lone pairs. So the hybridization becomes sp3d. And what about SF4? SF4 once again, that is sp3d. PF5, that is sp3d. They are asking for at least one lone pair at the central atoms. So if you could see XeF4, I am drawing this texture for SF4, sorry. So that is, will look like this, isn't it? So lone pair is residing here, so which makes this as your right answer. In case of PF5, there is no lone pair. All are bond pairs, and remaining xenon is having its more than one lone pairs. No, yeah. Then the next question is for the reversible reaction. A is equilibrium with B plus C. The degree of dissociation at pressure PT then. Okay, so this is purely very easy question. Reversible reaction. Reversible reaction means you have to consider Le Chatelier principle also. Okay, so what it says, if pressure is getting increased, so it will go to compensate that, right? So if the total pressure is getting increased means the reaction will go to backward direction, so dissociation will get decreased. So the total pressure increases, then the degree of dissociation decreases. Okay, so the next question, the number of unpaired electrons and hybridization of manganese Cn6 3-. So let's find out the oxidation state, that is 3+, so which means 3d4, 4 is 0. So 3d5, 4 is 2 is its ground state. Then the oxidation state is 3d4, 4 is 0. Okay, so number of unpaired electrons and hybridization. So how many unpaired electrons are there? So total 1, 2, 3, 4. It is in ground state. So this is a strong field ligand which will do the pair up. So that it will form 2 space in D2. So D2 sp3, that is its hybridization. Then how many unpaired electrons are there? 2 unpaired electrons are there. So answer to this question is 2 and D2 sp3. So keep practicing more and more questions. I will update you the questions as far as I get. So all the best to you guys who are attending the test tomorrow. So hope you'll rock it. Don't worry. Practice questions. Keep your mind calm. All the best for your exams.